So, just to summarize here, so far the matrix operations we've talked about were addition and subtraction. And to be able to do addition or subtraction, we need to have equal dimensions. And we're just going to do that addition and subtraction corresponding element to corresponding element, right? So we add the first, row 1, column 1 thing together, add row 2, column 1 thing together, et cetera, et cetera, et cetera. We have scalar multiplication. We can always do this. Here we just multiply the scalar to everything in the matrix. We talked about matrix multiplication, so I'm just going to say A times B just so that I have something to talk about. So for this, we need the number of columns in A to equal the number of rows in B. And then we to get each element, we multiply the corresponding elements in a row of A to the corresponding elements in a column of B, and then add them up. Let's just say, and then add the products. That'll be a little bit more clear. And yesterday we had left off talking about this inverse matrix. This was the last thing that we were talking about last time. When I say yesterday, obviously you guys don't mean yes. No, I don't mean yesterday, right? The last time we were in class. I keep on saying it and I'm like, that wasn't yesterday. But I just keep on doing it because it's stuck in my head from the old schedule where we'd meet every day. Well, the old schedule where we met every day. Last year's schedule, sometimes we met consecutive days. Okay. So to be able to do this, we need a square matrix. And, oh, did we define that yesterday? We didn't. We're going to do this in a second. And the determinant of A needs to equal 0. I know. You guys don't know what the determinant of A is. What do I mean by I say that? We'll circle back to that in just a moment. N by N? That's okay. Again, if there's something you don't remember, you're doing the right thing to ask. Is this helpful to just kind of summarize this all in one place? So we've been kind of having a conversation about these things, so our notes, I'm sure, are kind of all over the place. But we're getting here to the end of stuff, so it's a good idea to summarize this. So if A is the 2 by 2 matrix, A, B, C, yes. Yes. And I know, we haven't said what that is yet. That's the last thing that we'll talk about here today. And then we'll do a couple of examples and we'll let you guys do some practice so that you can ask questions and try stuff on your own. Oh, sorry. Very important. The determinant has to be non-zero. Non-zero. Not equal to 0. Not equal to 0. There's a lot of nots. So the second piece is just the formula that we can use to find our inverse matrix for a 2 by 2. I will never ask you to do a bigger inverse matrix by hand. Okay. And the last thing, the last matrix operation is this idea of a determinant. So again, to be able to take a determinant, we need a square matrix. And the way we write this is we either write the determinant of A, like det of A. Oh, thank you. Or more commonly, we'll write the matrix A with vertical bars around it. Now that's confusing for you guys because it looks a lot like the absolute value. But that's not what we're saying. So that's indicating the determinant of matrix A. We know it's not referring to an absolute value because there's no such thing as an absolute value of a matrix. That's not something that exists. That's the notation we'll use for determinant, and it's probably the more common of the two notations. It's the one that I'll use when I write things in the homework. So if A is the matrix ABCD, the determinant of A is just AD minus BC. That's just going to be a number. The determinant of a matrix is just like a regular old real number, like 7 or 15 or negative 12 or 0 or 1/2 or whatever. It's just a number. And if you recognize that, yesterday when we looked for that inverse matrix, this was the denominator of all the fractions in our inverse. Right? So that's where this determinant of A is coming from. Yes. A times B minus B times C. Yes. So I expect that you're able to do a 2 by 2 determinant by hand because literally you multiply two numbers together and you subtract them, like, woo, or two pairs of numbers and subtract them. That's tough. I'd also expect that you're able to do this for a 3 by 3 matrix. So that's the formula that we'd use to calculate the determinant for a 3 by 3 matrix. I would encourage you not to try to memorize this formula. I'm going to show you the visual trick for how to do this calculation. Because it's pretty easy from a visual standpoint to remember how to do this. This formula is like an alphabet soup of confusion. So I would not encourage you to use this to try to memorize this formula. I'll show you the process. I would just work on memorizing the process because it's pretty easy. A pretty easy process. It's quite visual, so it's I think considerably easier to memorize than like this combination of, with 18 letters is kind of a lot going on there, right? Okay. So let's just do some examples now of these calculations, and then we'll spend the rest of the time today letting you guys work on some assignments. Okay? So let's say we did I asked you to do this. This is one you should be able to do in your head. Anybody have the answer to this yet? Mia? Yeah, this is undefined. Why is that? Yeah. So that turned out to be pretty easy to do. Am I going to do something like that on a test? You better believe it. Very important that you, before you start trying to do any multiplication problem, that you check to make sure we can actually multiply them together. So this one is possible, right? Since the rows of the first match or the columns of the first match the rows of the second. So I'm going to get I know that my answer is going to be a 3 by 2. So I'll multiply the rows of the first to the columns of the second. And I'll just keep doing that, row times column. So let's see, 14 plus 15 is 29. 21 plus 18 is 39. 4 plus 25 is 29. 6 plus 30 is 36. 2 plus 0 is 2. 3 plus 0 is 3. Everybody okay with how we do this matrix multiplication? This is like, we've done several examples now of doing this. Should be okay. Obviously, you probably need some chance to practice to get it, to make sure you got it, but that's the plan for today, so. And if you get stuck or you're clueless, you can always come talk to me more during today to get back up to speed or whatnot. So let's say we want to find the inverse matrix of 5, 4, 3, 2. So there's two things we need to check to make sure that this is possible. The first thing is that it's a square matrix. Well, we got that part. Everybody okay there? The second part is we have to check the determinant. To make sure that's non-zero. And we're good there. So again, all we're doing when we check the determinant is we multiply the main diagonal, and we multiply the other diagonal, and then we subtract them. Right? That's all we're doing. Again, I don't think that you need to memorize a formula for that. I would much rather just visualize what I'm doing when I'm taking that determinant, where it's main diagonal minus the other diagonal, and it's easier to remember that, I think, than the letters going on. I'm an idiot and would definitely mix up the order of the letters, but the picture I can't forget. Fatty? Right. If it equals 0, you can't take the inverse. Mm-hmm. Okay. Everybody so far so good? Now I'm just going to follow the formula. So the formula says this is 1 over that determinant. And then it tells me how to alter the entries in matrix A to get the entries for that I need. So it says that the entries on the main diagonal switch locations. So we're just going to swap the locations for the things on the main diagonal. And then it says the things in the other diagonal get negated. That's just the formula that we wrote down earlier. Okay. And again, you could try to memorize that formula. To me, I'd rather just remember that rule that I said, where the main diagonal, you just switch those places, and the other diagonal, you just switch the signs. And I think that's easier to remember. At least would be for me. Mia? So yesterday, you remember we did this terrible solving systems problem at the end of the lesson that everybody kind of glazed over? Remember doing this? That's the result that happens, is that's the matrix that we get when we do that. So it is quite literally the because of solving that system. That's why we get that certain order with a certain size flaw. Because it seems pretty arbitrary. Like, why in the heck would that be what we need? And the reason is it's because it's the answer to that system that we solved earlier, that we didn't really finish solving because everybody looked positively horrified at going any further, which is fine. You got the point of it. And it's something I would never ask you to do by hand, alone, unreasonable. But it's a good exercise, right? Like, if you can solve that system and get those answers to pop out, you did a heck of a good job there. Anyways, we still have a little bit more to do because we have this scalar multiplication going on that we have to multiply. So negative 1/2 times 2 is negative 1. Negative 1/2 times negative 4 is positive 2. Negative 1/2 times negative 3 is just 3 over 2. And negative 1/2 times 5 is just negative 5 over 2. So this is our final answer. Everybody okay with that? So this is not hard, right, to find these inverses. It was hard to come up with the formula. That was really difficult. But to actually execute the formula, it's not so bad. At least for a 2x2. It's actually quite difficult to do this for a 3x3 and a 4x4, but we're not doing any of that stuff by hand. We'll talk about how it's kind of done, and then we'll use the calculator to do it. We'll talk about a little bit about the process the calculator uses to do it and kind of explain how that works. And then we'll just have the calculator do it. Yes, your calculator can do all these things. Okay. One more. What are we asking you to do in this problem? This is finding the determinant. How do you know that I'm asking you to find the determinant here? Yeah, because we've drawn vertical bars instead of brackets, so you have to be quite careful there. Those two things mean different, something different. Everybody's okay? Okay, so I gave you a terrible, terrible formula for finding the determinant for a 3x3. I'm going to show you a visual way of kind of doing this that's, I think, massively easier. So what we're going to do is we're going to start by recopying the first two columns of my matrix right here. Everybody okay with that? No problem doing that. That's easy to do. Now we're going to multiply along these three diagonals and add up the results. Everybody's okay with that? And then we are going to subtract or multiply along these three diagonals and subtract the results. And I'd wager that everybody's going to agree that that's a heck of a lot easier to remember than that formula that we wrote down a minute ago. I told you that you're going to like just memorizing or remembering the process was going to be much easier than memorizing the formula. Everybody agree with that? So now all that's left is to do this multiplication. So 15 plus 0 plus 14 minus 0 minus 0 plus 4. So that would be 33. And that's it. That's all I want to do today. It's just we've recapped what we've done. We got everything into one place. We've done some more examples of these operations that we haven't done so far. I would say that we can spend the last 30 minutes or so of class working on the homeworks. So at this point, you should be able to do homework 8. You should be able to do all of homework 9. And homework 10 is still, we need to talk about that. So we'll start talking about those skills on Friday. But you should be able to finish homeworks 8 and 9 today. If you have questions on things, you can certainly come up and talk to me. And if you just want to check answers, I have the answers written down up here if you just want to check things. You're welcome to just come up and say, hey, can I look at the answer for number 12 or whatever? And like, that's cool, no big deal. But that's the plan for today, is just let you guys kind of get caught up on some stuff. I know it's getting to the hectic time of the year. So, does that sound good to you guys? Plus, if you get stuck on something, it's nice to be able to, like, ask a question and be able to move on to it, not have to wait till the next day, right? Most of these things are not, like, terribly difficult, but they're all brand new, which makes it kind of hard. So